Hi everyone, Lindy Elkins-Tanton here again. I'm here to talk to you today about the problem set that you advanced inquirists, those of you who are in 496, need to do. Now this is to take you a step beyond the kind of inquiry we've been doing. Usually in science-based classes, engineering classes, you're given problem sets. So your instructor hands you a whole list of problems that you need to practice solving. But here what we're trying to do is prepare you to feel like you can break down the world around you into a series of approximatable, solvable problems that you could make estimations about. And so in this class, you're going to write the problem set and then solve it. And there are 3 steps in this problem set. There's the problem set part where you create the problem and solve it yourself and check that it's reasonable. Then you're going to give a colleague a peer review of their draft, and you're going to get one back from a colleague, and you're going to respond to those reviews. So you're going to practice giving each other helpful feedback. And finally, you're going to take some important part of this and you're going to put it into your digital portfolio. So what's the story with making up your own kind of problem? These are often called Fermi problems or order of magnitude problems. The idea is to use your understanding of a question that you have to make a kind of an estimate of what an answer might be, and then to check its reasonableness. And I will take you through the steps in a moment that we're going to expect for you to do for that. Okay, now let's talk about this problem part of the problem set. I have to put on my glasses so I can check my notes. The first thing you're going to do is you're going to do a problem formulation. You're going to formulate the question that you're hoping to answer. In this class, your question has to have something to do with space science, but I'm going to give you some examples from a non-space kind of perspective that might give you an idea. One example might be, how much water does my household use in a year? This is not something that you immediately know the answer to. It's not even necessarily easy to find through your billing cycle or anything like that, but it's something that you can approximate as a Fermi problem. You could think about, how long would it take me to build my own house? You could do the classic Fermi problem, which is, how many piano tuners are there in Chicago? These are things where you can set up a series of assumptions and then calculate an answer. So that's the first step, to formulate. Sometimes your natural next questions could turn into problem set questions. So start thinking early about the kinds of questions you could ask in your problem formulation. Second, you're going to come up with some solution logic. And the way I would suggest you go about this is to ask yourself, what are some key parameters that might go into influencing the answer that I'm looking for? If I'm thinking about how much water does my household use in a year, then I might think about, for example, N, the number of people in the household. That's going to be key. Another one might be the volume of water that's used in washing people, so washing water. Another one might be the volume of water used for drinking. You can go on and on. The amount of water that you use to wash clothes, the amount of water used in cooking, how much water do you use in cleaning the house? What about if you irrigate your garden? What about if you wash your car? All the different uses of water. But in the very simplest sense, if we're just looking at this, then we put this together with some math and say the answer just using these parameters, which is not complete, would be the number of people in the household times the sum of the volume used for washing plus the volume used for drinking. Now notice you're going to have to pay attention to the time scale. Volume used for washing over what period of time? Volume for drinking over what period of time? And then there are going to be more parameters that you're going to want to put in here. But that is basically the idea for the solution logic. Your next step is going to be using some math or coding to create an answer. Now I don't want you to freak out if that seems scary to you, because I just need you to come at this at the level that you're at. Now if you're an advanced graduate student or you've done a bunch of math study, you might say, I can just look at my problem formulation and think about the parameters, and I could write a differential equation, and then I could write some code that would approximate an answer, and I could give you a solution space, and that's fabulous. If that's where you're at, go for it. But if you're at the point where I'm going to write down these parameters and then I'm going to make some estimates and plug them in and do some addition and multiplication because that's my level of comfort, perfect, that's great. Absolutely great. What I don't want you to do is go find a fancy piece of prepackaged computer code and use that. I want you to do this yourself at whatever level you're at, and you are going to be graded on your math or coding. You've got to put some math or coding in there. So that's step 3. So then the next step is going to be your reasonableness check. You know, back when we were in 6th or 7th grade, we would do our little computation for our math class, and we would get an answer, and there it would stand until the teacher said yes or no. This is right or this is wrong. But now that we're grown-ups living in this free space of the real world, we have to ask ourselves, is the number I came up with in step 3 reasonable? Do I think it's probably trustable? Is it close to being right? And what I want you to do is find a way to check your answer. That does not mean walking me back through the logic that you used to get to it. It means finding an alternative way to estimate, a different source that made a similar estimation, some other way that would give you a reason to think that your answer was right or wrong. If you do your reasonable check and it's like, my answer is not reasonable for the following reasons, perfect. You do not need to redo your problem set. You just need to tell me, is it reasonable or not reasonable, and here's why. So that's the reasonableness check. And number 5 is hand it in. So those are the steps you're going to go through for this problem set. So go. Okay, after you've done a draft of your problem set, you've done this whole thing, and you've got a complete draft of what you're doing, then we're going to do a peer review. So here you are with your hair, and here's your draft. And you're going to give it to me, and I'm going to pair you up with another student in advanced inquiry. And so then another person is going to look at your draft. And they're going to give you some feedback. They're going to use a form that I'm going to give them, and they're going to write some feedback on there that is meant to help you make a better draft. Meanwhile, you're going to have received someone else's draft, and you're going to read it, and you're going to give them feedback to help them make a better draft. After that, I will give you your review back, and then you get to respond to it. And so after you get your review and you think, wow, you know, that was super helpful, or here are the ways this could have been more helpful review, then you get to give your opinion back about the review that you got. And so does your colleague get to give you an opinion about the review that you gave them. And so this is really kind of modeling the actual workplace, where I do a piece of work and I need to bring it to my colleagues and ask them, could I have done this better? What flaws do you see? What would you add? And they give me suggestions, and I look at it and I make the draft better. This is kind of like what grading should be. Really, it should be teaching you how to do something better and giving you a chance to try again. So this is going to happen, this peer review process, and then you're going to make a final draft based on everything you've learned from your peer reviewer and things that you've thought of in the meantime, and then you're going to hand in your final draft. And that's how the problem set goes. There is a third part, which is to put some of what you've done into your digital portfolio so that you can use it actually later in life in a job search or showing some of the work that you've done for a purpose. And so if you're in the technological leadership major, you will also have to do that third step, and we'll give you directions on that separately. So there you have it. That is the problem set for advanced inquirists.